everyone. So I want to share with you today the microservice that I have built based on Cassandra for a cloud data storage solution which BMC has produced. First of all, I want to share the reasons for building a custom microservice. The first question that comes to mind is there are so many storage solutions available, then why build yet another one? And that's the first question that I want to address. So the primary value proposition of our solution has been that whatever data is supplied by the user, we take it and we store it, and we also enrich it and augment it. We don't reject anything. Even if it gets rejected for lack of error, or whatever, it is still stored somewhere. So that is our first value proposition to the customer. Now, enriching and augmenting that information means deriving metadata out of it, identifying types out of it, and building relationships, all these which are important in the solution which we are planning to offer. Hence, when I evaluated many other solutions available, graph databases, other NoSQL databases, regular relational databases, there was some factor that was missing. So in a relational database, I could store graphs, I could by flattening them, but building relationships and searching them was a bit difficult. Graph databases either were not free, the top solutions in that space are not free, and those which are free had serious performance constraints. Secondly, when we were addressing missing data which came out of order or which was incomplete, it was not possible to store it in a graph database. So, and then I also needed a space storage where the column definitions could vary depending on the object. So in a relational database, one has to allocate storage for all these objects and for all these properties, whether or not there is data, because that's how the proposition of the relational database works. So for all these reasons and for performance and horizontal scalability reasons, I finally wound up choosing Cassandra, which is a battle-tested solution. So in this presentation, I'm going to share how I came up with the solution and certain design challenges, how did I address them, and also how did I leverage whatever features Cassandra has to offer to build a useful and a meaningful solution. So here's an overview of the proposed solution that we are sharing. So the Cassandra database as well as the microservice is deployed in separate clusters in the cloud, and the service is fronted by REST APIs. So that is the primary entry point for data to enter the microservice. So data comes in the form of JSON over HTTP, and the REST API accepts it. First thing it does is store it, and then all the enrichment happens asynchronously. So I'm going to talk about how the flexible schema was implemented using Cassandra. And here in this diagram, you can see that I have a device data coming in. So it has 4 properties. So when the data is stored in the Cassandra database, the column definitions are created for those 4 properties. When the next object comes in, it has a few other different properties which do not exist in the column definition. At runtime, the schema of the table is extended in the backend, and then when those properties, columns for those corresponding properties are created, the data is stored in the database. The advantage of Cassandra is that when you extend table definitions in this way, tables can be very wide. They can have actually millions of columns. However, only columns for which there is actual data is allocated space in the database. So even though there are other columns in the table, only if there is data for them, you get space for it on the disk. Otherwise, they are just part of the metadata of the database. This proves to be a very efficient way of storing data in Cassandra, and that is one of the Cassandra features that I have leveraged.